What really separates a modern switch from an old shared hub? A switch builds a MAC address table and forwards each frame using it. It learns source addresses and sends frames only to the port that needs them. But the deeper story is how a switch divides up a network. To see why, it helps to recall the old shared hub. A hub was one shared wire, placing every device in a single collision domain. If two devices transmitted at the same instant, their signals collided. They had to detect the collision, back off, and retry, a scheme called CSMACD. Because only one device could really talk at a time, this was half duplex. A switch changes this picture completely. Each switch port is its own separate collision domain. With only one device on a port, collisions simply cannot happen there. That lets every link run in full duplex mode. Full duplex means a device sends and receives at the same time, doubling throughput. Switches also differ in how quickly they forward a frame. Store and forward reads the entire frame and checks the FCS before sending it. This catches corrupted frames, but it adds a little latency. Cut through instead starts forwarding as soon as it reads the destination MAC. It is faster, but it can pass along a frame that turns out to be corrupt. Now think about broadcasts, like an ARP request meant for everyone. By default, every port on a switch sits in the same broadcast domain. One broadcast therefore reaches every device connected to that switch. LANs let us split one physical switch into several logical networks. Each VLAN becomes its own separate broadcast domain. Devices in VLAN 10 cannot hear VLAN 20 broadcasts without a router. Collision domains per port, broadcast domains per VLAN. That is LAN switching.